Have you ever, looked at the same picture on your phone and then on your TV and thought, wait, that looks different?
Oh, absolutely. It's not just you imagining things.
Right. So there's this whole hidden world of color standards dictating what we actually see.
Exactly. Complex stuff, but fundamental.
Today, we're diving into two really big ones, Rec. 709 and P3. We want to figure out how these shape, well, everything we see digitally.
Sounds like a plan. They're both incredibly important, but for different reasons.
Let's start with Rec. 709. It feels like the foundation, doesn't it? It gave us HDTV, sure, but it also sort of standardized what color meant on TV for decades.
It really did. It created a shared visual language.
Yeah.
Everyone watching HD saw basically the same colors, which was huge for broadcasting and SDR content. It was, and often still is, the reliable default.
But technology marches on. People wanted more, right? More vibrancy.
Precisely. Creative ambition met technological limits. Rec. 709 was great for consistency, but filmmakers especially felt constrained. They needed a wider palette.
And that's where P3 steps in.
Exactly. DCI P3, its original name, came directly out of digital cinema needs around 2005. They wanted richer, deeper colors, think film-like saturation, that Rec. 709 just couldn't capture.
So Rec. 709 is safe, compatible. P3 is more ambitious.
You could say that. P3 is now vital for high-end workflows, especially HDR. It dramatically expands the creative possibilities.
Okay, before we get lost in the acronyms, let's back up slightly. Color space, color gamut. Can you break those down simply?
Sure. Think of a color space like a language for color. It's a mathematical model defining how colors are represented numerically.
A map, sort of?
Kind of, yeah. And the gamut is the specific territory on that map that a particular device, like your screen, can actually show.
Okay.
We often picture it as a triangle on the CIE 1931 diagram. That big map are all human visible colors.
And what defines this space, this triangle?
Three key things: specific red, green, and blue primaries, the base colors it mixes, the white point, what it considers pure white, and the transfer function or gamma curve, which affects brightness and contrast.
Got it. So, Rec. 709 officially ITUR BT.709, right? Approved back in 1990.
That's the one. Its goal was unification for HDTV. It set the standard. D65 white point, which is like daylight neutral white, and originally a gamma, well, now standardized at 2.4 by BT.1886.
And its gamut size.
It covers roughly 35.9% of that CIE map, designed for consistency above all else.
Which it achieved, but then cinema needed more, leading to DCI P3.
Yes. Developed for digital projectors in dark cinemas.
Yeah.
Significantly wider gamut, about 53.6% of CIE 1931s. That's a big jump.
Especially in certain colors.
Definitely. Much richer reds and greens. It uses a different white point, closer to a xenon lamp, and a gamma of 2.6, optimized for that dark room viewing.
But DCI P3 was for cinemas. How did it make the leap to, say, my phone or laptop?
That's Display P3. Apple really pushed this. Starting around 2016, they took the wider DCI P3 primaries, the vibrant colors,
right,
but adapted it for consumer viewing. They switched back to the D65 white point, like Rec. 709, and used a gamma closer to 2.2, similar to sRGB.
Making it work better in brighter rooms, like where we usually use our devices.
Exactly. It brought that cinematic vibrancy into everyday use.
So visually, P3 just contains more color than Rec. 709.
Pretty much. If you overlay the gamuts, the Rec. 709 triangle sits comfortably inside the larger P3 triangle. It's a noticeably wider range.
This explains so much. Like when I edit something and it looks fine, but then looks way too saturated or maybe dull on another screen.
That's the challenge. The golden rule for creators is edit in the color space you plan to deliver in. Rec. 709 for broad compatibility, SDR web, broadcast.
That's a safe bet.
Right. And P3 for anything aiming for that higher end HDR cinematic feel. But mismatching causes problems.
Like what?
Rec. 709 content on a P3 screen can look overly bright, almost cartoony sometimes because the colors get stretched.
Okay.
But maybe worse is P3 content on a Rec. 709 screen. Those extra vibrant colors P3 offers, they just get clipped, they disappear. The image looks muted, losing the artist's intent.
So you're literally not seeing the full picture. What's the next frontier then? Is P3 the end game?
Not quite. The future standard, especially for UHD and advanced HDR, is Rec. 2020. Its gamut is massive, pushing much closer to the limits of human vision.
Wow. So where does P3 fit in then?
It's actually serving as a crucial stepping stone. Many modern HDR formats technically use a Rec. 2020 container, but the actual content inside is often mastered in P3.
Ah, like a bridge technology.
Exactly. It bridges the gap until displays can routinely hit that full, huge Rec. 2020 gamut.
So Rec 709 and P3 aren't really rivals. They're tools for different jobs from different eras.
Perfectly put. Rec 709 is the reliable workhorse. P3 provides that expanded, richer palette for modern experiences.
Understanding this stuff suddenly feels really important for anyone who cares about visuals.
It is, and that's why things like color management, calibrating your monitor, they're not just for pros anymore. It matters for how accurately you see the world, digitally speaking.
It really makes you think how much of what we perceive as real on screen is actually shaped by these invisible technical frameworks.
It's a fascinating thought, isn't it? Mastering these differences isn't just technical. It's part of the creative journey, giving storytellers a bigger, better box of crayons to work with.